Hi friends, in this video I am going to explain about exponential form of Fourier series. Here the exponential form of Fourier series of periodic signal x of t with period t is defined as, how to define that one means x of t is equal to summation n is equal to minus infinity to infinity cn e power j n omega naught t. Here omega naught t is equal to 2 pi by t. We already know that one, that is a fundamental frequency which is nothing but radians per second. N omega naught t is equal to what? Harmonic frequencies. These are harmonic frequencies. And Cn is nothing but Fourier coefficient of exponential form of Fourier series. Now how to represent this Fourier coefficient of exponential Fourier series? So which is given as, Cn is given as 1 by t integral 0 to t x of t e power minus j n omega naught t. Right? Now consider the exponential form of Fourier series, that is x of t summation n is equal to minus infinity to infinity cn e power j n omega naught t. Now from this exponential form of Fourier series, we have to find out the component value. This equation, how to find this equation? So that is, expand the series first. The value starting from here, I am taking it as minus k to k, right? That is, substitute negative values as well as positive values. Here I am taking infinity values, minus infinity to infinity, so here and so on, plus c minus of k e power minus jk omega naught t plus and so on, c minus 2 e power minus j2 omega naught t plus and so on, plus c minus 1 e power j omega naught t plus c naught plus and so on, c1 e power j omega naught t plus c2 e power j2 omega naught t and so on, ck e power jk omega naught t. Let us multiply e power minus jk omega naught t on both sides. So if you multiply this exponential part, you have to multiply on both sides. So in left hand side, you have to multiply with x of t into e power minus jk omega naught t is equal to and so on, plus multiply this whole term with e power minus jk omega naught t and so on. Again this term into e power minus jk omega naught t and so on. So if you multiply this term into e power minus jk omega naught t, so both are getting cancelled, you are getting only ck value, right? Now after multiplying e power minus jk omega naught t on both sides, let us integrate the above equation between the limits 0 to t. You have to integrate both sides with limits 0 to t. The integration of x of t e power minus jk omega naught t dt is equal to and so on. For every term you have to integrate with limits 0 to t, right? So e power minus k omega naught t minus jk omega naught t into e power minus jk omega naught t, we are getting e power minus j 2k omega naught t into dt. Okay, remaining terms as it is you have to multiply. Okay, so the equation which is having the exponential part all are 0 except this part, right? So here integration of 0 to t ck into dt, right? Ck is a constant and the integration of 1 is t with limits 0 to t, ck into t minus 0, right? So integral 0 to t x of t e power minus jk omega naught t into dt is equal to t into ck, right? Here ck is equal to what? 1 by t integral 0 to t x of t e power minus jk omega naught t into dt. Now the above equation given the kth coefficient, that is ck. If you find out for nth coefficient means Cn, that is Cn is equal to 1 by t integral 0 to t x of t e power minus jn omega naught t. That is nothing but this one, Cn. Whatever we have seen in the first, that is Cn value, we have to find here, find out here. Cn is equal to 1 by t integral 0 to t x of t e power minus jn omega naught t into dt. So this is the exponential form of Fourier series. Thank you.